Saccharides. So we know this. We've heard it before. Your brain runs on glucose. You need that short packet of fuel to trigger brain activity. And we're in Native America. We're actually in North America. And North America has a very interesting thing as compared to every other continent except for Antarctica, in that it is notoriously low in carbohydrates. Like the Native Americans here had a very difficult time procuring enough carbohydrates. We don't realize that today. We don't realize that oranges were brought to Orange County from China. We don't realize that the apple varieties, the several thousand apple varieties, most of which came over from Europe, there were wild apples in North America, but they weren't the kind of apples we have today. They were little crab apples and they were sour. There was grapes here in North America, but they weren't the European varieties, the wine varieties, the grape varieties that had been grown for thousands of years in Europe and cultivated. There wasn't a lot of sugar there. And there wasn't a lot of sweets around. So the Native Americans had a very difficult time procuring carbohydrates. And actually, Native Americans are more sensitive to carbohydrates as a result of that because they had to live on a low carbohydrate diet. But you need carbohydrates in order to keep this thing functioning. So what they did is they would put acorns in a stream, leach the tannins out, pull them out of the stream after a couple of weeks, crush them down, dry them out, crush them down, dry them out again on rocks to make like a flatbread, because acorns have about 30% carbohydrate. And so they're a reasonable source of carbohydrates. So all across Native America, North America, you find that Native Americans had to live on acorns because there wasn't any fruit around. They weren't beekeepers, so there wasn't any honey around. This is interesting, isn't it? And really, you don't even have beekeeping really in North America as far as I've been able to tell until the Europeans came over. But you do in Central America. They were more on top of it. But then in Central America, you've got way more fruits. You've got the tropical fruits. So they didn't have a problem with procuring carbohydrates. So procuring carbohydrates is actually an important part of brain fuel. And we got to bring it, in my opinion, all the way back to like, how did we live on this earth originally? And how do we do this? And how do we solve these problems in order to get a complete understanding of it that's beyond like where we are now, which is our health food store reality. So we have a deeper presence with it. You know, we have a deeper wisdom about it. So fruits, berries, honey, and then you could, of course, dig up roots and cook the starch, right, to convert the long-chain sugar to short-chain. If you dig up a root, generally like a potato, and you try to eat a potato, it's like, bleh. But if you bake it or you cook it, all of a sudden it's like, oh, it's like sweet, it's sugary. So what you've done is you've actually changed the starch into short-chain sugars to activate brain, which we need. Okay, let's keep going. Now, the other side of this is the polysaccharides. Now, short-chain glucose molecules, like little glucose molecules, are like a twig. And if you look on this picture here, you can see we've got a pig and we've got a fig, a twig, a fig pig, and a twig, in a tree, and a tree. So this is more like, you know, a short-chain sugar. It's just a little twig. But a tree with its convolutions and all of its little twigs and all of its little branchings, that's more like a polysaccharide. So these carbohydrates are carbon-hydrogen chains, and when they're small, like a 6-carbon chain, that's like glucose, or a 5-carbon chain, that's xylitol. But when it gets out to like hundreds of chains, that's like a polysaccharide. And these polysaccharides do have an effect on our brain, and they sharpen our intellect, and they're part of what creates the connective tissue of our brain. These are things that come up a lot in medicinal studies, right? When you're trying to figure out what does our immune system run on? This has all been completely figured out, exactly what your immune system eats and how it all works. And I put all that information into my Chaga book, which is coming out. Chaga, King of the Medicinal Mushrooms, September 2012. It's coming out. What a research project that's been. Unbelievable. And I had to go through and rewrite it a bunch of times. So I'm like, it's really embedding in. I'm like, whoa, okay, now I'm getting it. These polysaccharides are very predominant in certain foods, and these are foods that you actually need to really have a real sharp intellect. One of those classes is the medicinal mushrooms. Chaga is a medicinal mushroom, reishi is a medicinal mushroom, cordyceps is a medicinal mushroom, and their active components are polysaccharides. They're real long-chain sugars. Generally, to the taste, they're going to be somewhat bitter. They're going to be somewhat bitter to the taste. But they sometimes can actually even get almost a buttery flavor. Because to my mind, in my research, if a carbohydrate keeps going, it becomes an oil. So basically, you have the beginning of carbohydrate formation in nature is when a spring comes out of the ground. It's called sweet water. And this is what you learn as a spring water hunter, is you find out, it's like, oh, sweet water, what does that mean? It's the beginning of carbohydrate formation in nature. You drink the water, and you're like, oh, that's sweet, because it has some kind of beginning of carbohydrate formation. And then plants take it up, and they'll actually assemble it into like a fruit, and that's like glucose. Or birch trees take it up, and they turn it into xylose or xylitol, right? And they assemble it. But as it gets longer and longer and longer, then you have polysaccharides. But if it keeps developing, then you have oils, the development of oils. Just want to put that out there, because this is going to transition us over into oils.